Well, I think part of it is that, if we take a concrete example, there are exceptions that are traveling through your code, some of which are related to kind of application operations that are failing for one reason or another and that you can reasonably handle. And then there are other exceptions flying through your code that are kind of unrelated to what you're thinking about when you write that code, that are related to things like app domain unloading, stack overflow, and out of memory realistically, because most developers don't think about running out of memory line by line in the code that they write. And realistically, that's a kind of an unproductive thing for them to be thinking about as they write each of those lines of code. They want to be thinking about, whether the file that they're trying to open actually exists on the machine, whether maybe they have sufficient rights to access it, that sort of thing. They don't want to be wondering whether the two strings that they put together to compose the file name, that's the last 46 bytes in the system, and we're going to give you an out of memory right there, and the whole thing's going to come cascading down. So to take those things that they're not thinking about and handle them kind of more declaratively, more globally, and more sensibly, using kind of process level policy, maybe making it easier for them to separate durable critical state from the transient state of the application, so that if we do need to kind of tear parts of the app down, that kind of the document or whatever they're working on isn't affected. Those are kind of far more productive ways to kind of have managed developers writing apps than to be doing it kind of the traditional way of every allocation needs to be checked. Particularly since in managed code, a lot of those allocations are rather implicit, like boxing under the covers, and because there's so much kind of substitutability and polymorphism in the code they're writing, that you really can't reason about exactly what you're calling and exactly what its behavior is with respect to things like out of memory. You kind of have to take a more global approach.
This is one of those problems, dealing with out of memory conditions. It seems like one of those problems that's been just completely impossible to solve seemingly for decades. It's ever since the computer started.
That's right.
How does the CLR make it, I mean, why is it that we think that we can make this problem easier today?
Well, so historically there have been kind of three approaches to dealing with out of memory. There's the approach that probably the vast majority of applications take, which is to completely disregard it, assume it won't happen, and kind of not even necessarily fail in a nice, clean, hard fashion, but to kind of crumble when the out of memories come through, because they're not really differentiated from other exceptions that might be traveling through the app, right? So even the failure mode isn't a nice, predictable failure with guarantees about whether the kind of the consistency of the app is preserved, and whether the document or whatever other kind of critical state is preserved. Then you've got kind of the traditional OS approach, which is that you harden. You can harden the kernel, and then you take it to the next level, and you harden layers above it, like the shell and other parts of the operating system, and you kind of push that out into the apps above it, so you harden Office, and every allocation has to be checked, and there have to be kind of degraded pathways that kind of shut down, and it's it's a reasonable approach to take in kind of a constrained world like the kernel, but it really doesn't scale, and it really isn't appropriate to most developers.
And it also has wildly horrible effects on productivity for the developers, right? So
yeah.
5 lines of code
that's
for
right.
every piece of log.
And you also from a testing perspective, it takes huge resources to gain confidence through testing. And even from a user perspective, first of all, the rate of those failures compared to the rate of other failures might not warrant that level of attention. You might prefer as a user for it to go elsewhere in the product. But when different pieces of the app kind of degrade, like you click on a button and it might fail to animate, did it actually do the job and not animate? Or is it going to animate later because it's paging? From the user's perspective, the app may be considered broken anyway. The fact that it's kind of partially up really isn't that interesting. So I think that in some ways, of course, SQL Server with the work we've done in Whitby and Yukon is kind of a one very reasonable way of building apps that don't have to worry about out of memory. It obviously works far better in a transactional environment than it would for traditional client app. But if you look at the way we approach the problem there, we say SQL Server is inflicting out of memory into the managed apps constantly, because as they're trading off between buffer pools and application memory, there can be a steady stream of out of memories going into the application. And the reasonable thing to do is to say the application really can't handle those out of memories, doesn't expect it, didn't build itself to deal with them. And when they occur, we simply rip down some reasonable part of the application so that the rest remains consistent, and try again, or try again later when more resources are available. And in a transactional world, that kind of rip down is fairly easy to achieve.